Good afternoon, everyone. So, I am Arian Mayar Pumarca, a MAED teaching mathematics student, and I am here to present my topic, which is all about sets and real numbers. So, first, what do we mean when we say sets? Okay. So, the set is a collection of distinct objects. So, meaning to say, in a set, it is a collection of distinct objects. So, meaning to say, distinct, unique. So, each object is unique and does not repeat. So, the objects in a set, we call them elements. The object in a set is what we call element. So, to describe or show that an object is an element of a particular set, we use the symbol like letter E. We call it element of. So A is an element of A, meaning to say that A is an object of A, an element of A. It is contained in A. Okay, so for example, we have set of A, which is 1, 2, 3, 4. By the way, we name the sets using capital letters. So for example, set A is composed of elements 1, 2, 3, 4. So the name of the set is A, and its elements are 1, 2, 3, 4. And we use braces or brackets to contain the elements in a set. Okay? So we have different types of sets. Okay, first, we have the empty set, meaning to say empty. There is no element. Empty or null set. For example, the set of x such that x is a square root of negative 5. So it is considered an empty set because there is no square root, there is no square root of negative 5, right? If we are talking about real numbers, there is no really square root of 5, so this set is empty or null set or empty set. Okay, next type of set is the finite set. When we say finite, limited elements. So we can count the elements in the set. Okay, so we can show or tell the elements of a set. So it is fixed. Okay, so for example, 1, 2, 3, the set of 1, 2, 3, so many, limited, finite. We can count it, right? There are 3 elements. Okay, next is the infinite set or the unlimited elements. If we can count the finite set, the elements of finite set, then on the other hand, in the infinite set, we cannot count the elements because it is unlimited. So, for example, the set of natural numbers. There are many natural numbers that we can't even know what is the end of the natural numbers, right? So, meaning to say it is infinite. Am I getting across? Alright. So, next is subset. So, when we talk about subset, we use that symbol. Subset of. It is what we call subset of. Okay, so in that example, A is a subset of B if every element of A is in B. So, for a set to be a subset, the elements should be contained in the larger set. So, for example, there are 2 sets, A and B. So, the elements of A are 1, 2, 3, and the elements of B are 1, 2, 3, 4, 5. So, A is a subset of B because the elements of A are contained in B. Okay? That is subset. How about when we say proper subset? Okay, so A is a subset of B and A is not equal to B. So, meaning to say, 2 sets, a set can be a proper subset if it is a subset and not equal in elements. So, for example, set A is 1, 2, 3, and set B is 1, 2, 3, 4, 5. So A is a subset, is a subset, right? It's a subset of B and is also a proper subset. Why? Because their elements are not equal, or the sets are not equal. Alright? So, in subset, sets could be equal, but proper subsets, two sets cannot be equal. Okay? So, universal set naman, all elements under consideration. So, it is composed of, it is the largest set in a situation being considered. So, universal set. So, those are the types of sets. So, we now move on to the set operations. So, first, we have union. So, elements, this when we say union, these are the elements in A or B or both. So, meaning to say, all the elements in a set is the union of the two sets. So, for example, we have two sets here, A and B. So, A is 1, 2, 3, and B is 1, 2, 3, 4, 5. So, if we're going to get its union, we just combine all the elements of A and B. So, that is union. Elements in both sets. Next up is the intersection. So, when we say naman intersection, elements in both A and B. So, when we say intersection, the common elements between sets being discussed. So, the common elements. Okay, so for example, we have here again two sets, A and B. So, the elements of A are 1, 2, 3, and the elements of B are 1, 2, 3, 4, 5. So, A intersection B is 1, 2, 3. Why? Because those are the elements that are common in A and B. We do not include the 4, 5, the elements 4 and 5, because we're talking about intersection. Okay? 4 and 5 are in B but not in A. So, they are not included in the intersection. So, those are the union and intersection. We also have difference. So, just like in algebra, difference here is we just subtract the elements. Okay? Elements in A but not in B, or the other way around. So, for example, we have here A is 1, 2, 3 and B is 1, 2, 3, 4, 5. So, B minus A, so the elements of B subtracted by the elements of A, so what will remain is 4 and 5. Parang it's the other way around of intersection. If intersection talks about the common elements, here in difference talks about the elements that are not common in both sets. So, it's like just we are subtracting, okay? So, complement. What do we mean when we say complement? So, for example, when we say complement of set A, or it is called A prime, so those are the elements not in A. For example, we have a universal set 1, 2, 3, 4, 5, and we have set A 1, 2, 3. So, out of the universal set, the complement of A or A prime are 4 and 5. Why? Because those are the elements that not in A. Okay, am I getting across? Alright, very good. Okay, so those are the sets, all about sets. Now we move forward to real numbers. So, what do you know about real numbers? What comes into your mind when you hear the word real numbers? So, it states here that in mathematics, a real number is a value that represents a quantity along a continuous line, which what you call a number line. So, in mathematics, real number can be found in a number line. I guess we're all familiar with number line, right? Okay, since grade 7, we are familiar with number line. So, real numbers can be found in a number line. Okay, in which part of the number line? So, we have subsets of real numbers. Okay, so for instance, let the universal set be the real numbers. So, a subset of real numbers is a natural, alright? Natural numbers. So here, n is a proper subset or a subset of universal set. So what do we mean when we say natural numbers? So these are numbers that are used for counting. The set of numbers starts with 1. So natural numbers are also what we call the counting numbers. Diba? When we are counting, we do not start with 0. We start with 1. So these are the natural numbers. It starts with 1. These are the counting numbers. So starts with 1, 2, 3, 4, 5, 6, and so on and so forth. Can we find it in the number line? Yes, of course. We can find it on the number line. So those are the natural numbers. So natural number is a subset of real numbers, right? Okay, so next is whole numbers. So from the natural numbers, we can make a bigger set, which is the whole numbers. So natural number is a subset of the whole numbers, and the natural numbers is also a subset of real numbers. But whole numbers is a subset of universal set or the real numbers. Whole number is not a subset of natural number. Why? Because whole number starts with 0. While the natural number starts with 1, whole numbers are also natural numbers that are formed by adding 0 to the set. The only difference with whole numbers and the natural numbers is the 0. In whole numbers, we start with 0, while in natural numbers, we start with 1. Alright. So, thus, whole number starts with 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. So, these are the natural numbers, whole numbers rather. Next is the integer. Okay, so from the whole numbers, we can form another bigger set, which is the integer. So let I be the set of integers. So integer is a subset of real numbers. As you can see, integers, under the integers, we have whole and natural numbers, meaning to say, integer is a bigger set than the whole and natural number. Why? Because in integer, we now have the negative of the natural numbers. Okay? So the natural number starts with 1. So, including now, the integers now are formed by adding the negatives of the natural numbers to the set of whole numbers. So meaning to say, we include 0 and the negative numbers of the natural numbers. So 0 and the positive and negative natural numbers. So negatives are now added to this set. So those are integers. Okay. So next, we have the rational numbers. Now, what are rational numbers? As you can see, integers, whole number, natural numbers are subsets of rational numbers. Why do we say what is rational number? Rational numbers is composed, or the set is the set of all numbers which can be expressed in the form A over B, where A and B are integers, but B is not equal to 0. So the decimal representation of a rational number either terminates or repeats. So rational numbers are numbers that can be expressed in a fraction form, but the denominator should not be equal to 0, because in mathematics, if a fraction that has a denominator 0, what do we call that number? Okay, so it is undefined if the denominator is 0. Here, it is important that the denominator is not equal to 0, because it is not a number anymore. It is undefined. Okay. So this decimal representation of a rational number either terminates or repeats. So we have here an example of a rational number, negative 19 over negative 5. So it is a rational number because we can express it in a fraction form, and the denominator is not equal to 0. Okay, another is 40 over negative 8. So it is a rational number because it can be expressed in fraction form, and b is not equal to 0. Okay. So what do we say when we hear the word terminating? Terminating decimal is a decimal number that ends with a remainder of 0. So it ends, the decimal ends. Diba we have decimal that do not ends. Okay? So but here, terminating decimal is a decimal number that ends with 0. So in other words, may katapusan ang decimal. Okay? However, the repeating decimal naman, on the other hand, is a decimal number whose answer will have one or more digits in a pattern that repeats indefinitely. Okay, from the word itself, repeating decimal, there is a number in a decimal that repeats indefinitely. Okay, so we use the symbol bar above the number that repeats. So terminating decimal and repeating decimal are examples of or under the rational numbers. Okay, so we also have irrational numbers. So from the real numbers, we have also the rational numbers. However, irrational numbers are not integers, are not whole numbers, are not natural numbers. So irrational numbers is the set of numbers whose decimal representations are neither terminating nor repeating. These numbers cannot be expressed as a quotient of integers. So irrational numbers cannot be formed as a fraction, and it is not also terminating, and it is not repeating. So, kabaliktaran po ang irrational sa rational. So, for example, we have the pi. So, pi, the value of pi is 3.1415 and so on and so forth. And this, it does not end. But it doesn't also have a number that repeats. So, meaning to say it is a rational number. Okay, so pi is also considered as an irrational number for its decimal representation are neither terminating or repeating, and it cannot be expressed as quotient of integers. Okay, so those are, let's go back to our subsets of real numbers. We have natural numbers. These are the numbers used for counting, natural numbers or counting numbers. It starts with 1, 2, 3, and so on and so forth. So, examples of natural numbers are 2, 3, 5, 8, and 17. So, we also have whole numbers. So, these numbers are formed by adding 0 to the set of natural numbers. If the natural numbers or the counting number starts with 1, whole numbers starts with 0. So, examples of whole numbers are 0, 2, 3, 5, 8, and 17. So, we also have integers. Integers are formed by adding the negatives of the natural number to the set of whole numbers. So, in integers, we now have the negative of the natural numbers plus 0. So, is 0 a positive or negative integers? It is not a positive. It is not also a negative integers. It is a neutral number. Okay, so example of integers are negative 19, negative 8, negative 5, negative 3, negative 2, 0, 2, 3, 5, 8, and 17. Okay, we also have the rational numbers. So the rational numbers are set of rational numbers, set of numbers which can be expressed in the form a over b, where a and b are integers and b is not equal to 0. So the decimal representation of our number either terminates or repeats. Okay, so if a decimal terminates or repeats, it is a rational numbers. But however, if it does not terminates or does not repeats, it is a irrational numbers. So irrational numbers are numbers whose decimal representations are neither terminating or repeating. These numbers cannot be expressed as a quotient of integers or fraction. If you can form it as a fraction, then it is a rational number. If you cannot form it as a fraction, then it is irrational numbers. Okay, so that would be all for the sets and real numbers. Thank you very much.